recognize that a tangent line, this could be important, forms a right angle if it's connected to the center. All right, if it's a radius or if it's a diameter and tangent, this creates a right triangle. That's going to be useful in other problems. Not this one, but it's good information to know. But we have that CF is tangent to circle T at F. If CB equals 8, so let's go ahead and label CB 8. So that line right there is 8. And it says AB is 10. So from here to here is 10. And it says that CD is 9. It says find DE and CF. So these are two completely different problems. The first one says find DE. So I need to find this length here. I'm going to go ahead and I'm going to call it X. Let's just call it X. The two lines that are in question are this one and this one. Both of those are secant lines. When we're dealing with two secant lines where we know an exterior and an interior length, we have to remember that it's exterior times the whole equals the exterior times the whole length. So to solve for DE, I'm going to put it underneath. To solve for DE, we need to do exterior times the whole length, so that would be 8 times 18. Once again, exterior times whole is going to equal exterior times whole of the other one. Well, that's 9. Do not put just times x, because it's actually 9 plus x. This is the whole length, right? Whole. This is my exterior. Exterior times whole. Did I just shortcut this all the way? No, I did the whole thing. Okay, so we have 144 is going to equal, we could either divide 9 on both sides, or we could do the 81 plus 9x. When I simplify this, I'm going to come up with x equals 7. So that right there equals 7. Exterior times whole. The next one talks about CF. CF is tangent. This is tangent. This is secant. So this is a secant compared to a tangent. I'm going to call this line, let's call it y. Let's say we're going to solve for y. Well, once again, we're going to do our exterior times our whole. So that'd be 8 times 8 plus 10, which is 18. And that's still, even though this is tangent, it's still exterior times whole. It just turns out that the exterior is the exact same length as the whole, so this would just be y times y, or y squared, which is just going to be y equals 12. Hey, both those aren't hard problems as long as you remember that exterior times the whole, which we seem to be struggling with right now. All right, so if you get stuck on this, make sure you look it up. Exterior times whole. Whenever you see secant or tangent lines, that's what we're looking at. So if I ever give you a line that you know this part and this part, think about that. Is this the exterior times whole type question? Go through that checklist. That's probably the first one on the checklist. The next one might be triangles or something else. But the first one on the checklist should be, can I do exterior times whole? Are these clearer now? Okay. All right, so I just picked a splattering of questions, like I said on the test, things that people messed up, but we can get it correct if I put it on the final. So the first one says a triangle with side lengths 17, 31, and 34. So if this is a right triangle, this would be my hypotenuse, which means I can do a squared plus b squared equals c squared. So I'm just going to plug it in there. 17 squared plus 31 squared. I don't actually know it's equal, so I'll put a little blank. Has something to do with 34 squared. And rather than doing 34 squared, what I'm going to do instead is I'm just going to take the square root of both sides, so I just have the square root. So when I'm looking for my actual thing, we're going to do that. So if you actually do 17 squared plus 31 squared, and I take the square root of that, I'm going to come up with 35.4. And that is larger than what could be my hypotenuse. So we're not sure if that's a hypotenuse, but we know it's longer than that. So what that's telling me is my hypotenuse is too short. It is too short. So if my hypotenuse is too short, what kind of triangle is it? Yeah, it's going to be acute. So if you set it up like this, your side squared, take the square root. If it's equal to your longest side, it's a right triangle. If this side is bigger than what you thought was your hypotenuse, then it's acute. If this is smaller, if this side is smaller, that means your hypotenuse is too long, so it makes it an obtuse triangle. Did your question or are you stretching? Okay. The next one says the area of two similar triangles are 25 centimeters and 16 centimeters squared. What is the ratio of their sides? So my area ratio is 25 over 16. And this question was missed on the test too many times for me to ignore because it should have been a really easy problem. So it wasn't a ton of people who missed it, but enough because it should be a really easy problem. If your area ratio is 25 over 16, your common ratio, or your ratio between sides, or your ratio between perimeter, is just going to be the square root of this. So your common ratio is going to be the square root of 25 over the square root of 16, which equals 5 over 4. Super easy problem, but if you don't know that, it's a super hard problem. Where you're just like, I don't know, 25 over 16, man. Yeah. Could you have 4 or 5? Absolutely. Yep. Typically, whatever order they give it in, usually write in that fraction, but I would understand what you did. I wouldn't take any points off of it. If it's multiple choice, just realize that, A, maybe they picked the other one and they have it flipped. So if you had 4 over 5 and the only answer was 5 over 4, you know that's your right one. Okay, similar objects. Similar objects. Remember that similar objects all have the exact same angles. Angles need to be congruent between similar objects. So when I ask for a measure of angle W, measure of angle W is right here. It has to be the exact same thing as measure of angle C. Angles are always the same. The ratio comes in with the sides. So measure of angle W equals measure of angle C, which equals 28 degrees. So angles are always the same between similar objects. The difference comes in when we're dealing with side lengths. So there's a ratio. If you look, this is 36. This is 27. So what I'm going to do is I'm going to label this one as my top. I'm going to use those as my top numbers. I'll use this one as my bottom numbers. And so my ratio, if we look at R to T, it looks the same thing as O to N. So that would be 36 divided by 27. 9 goes into both of those. So this is going to be 4 over 3. That is your common ratio. That's my common ratio. I'm just going to do one of these guys. So the next one says find WN. So I'm going to look at the side that relates to it. Well, that's CT. So we're just going to go C to T, which is 28, over my WN needs to equal that common ratio, that 4 over 3. Well, now we just have to do cross multiplication, which will get me 4WN is going to equal 90 minus 6 is 84. Did I miss anything up here? No. So that means that WN is just going to equal 21. All right, any questions on that one? No? I'm going to let you do the next one. It is in the notes. I'll post those on Edmodo too if you want to get the second one or try it yourself and get that. We just don't have a ton of time. Okay, for this guy, it says find x and find y. So this is that geometric means type problem because I have a right triangle, so I can use the geometric mean stuff. Yes? I'm just going to find x and h because y is going to be pretty much given to me as soon as I find x. Okay, so we have two geometric mean things. We can use heartbeat or we can use bunny ears. If I use heartbeat, I have y over h, h over x. Does that help me solve for anything? No. So the next thing I'm going to try is the bunny ears one, which is 30 over 18, 18 over x. That's going to make more sense, right? Well, I'm going to draw it up here. So it's the bunny ear method. So it goes full length. So whatever our full length is, so that's going to be 30. Over, and we come up. So it's over 18 is going to equal come back down. That's 18 still. And then come back here. It's a stretch, but it kind of looks like bunny ears. All right, so that's 30 over 18 equals 18 over x. That's going to simplify down to, let's go back to black. 30x is going to equal 324, and our x is going to equal 10.8. So x is 10.8. So this distance here is 10.8. So that means we can easily find y, because that's 30 minus 10, which is 20, which is going to be 19.2 is my y. All right, so I took care of bunny ears. So now let's do the heartbeat method. The heartbeat method is going to get me h, because heartbeat always gets this length here. So if we use the heartbeat method, we're going to go across. Does that stand out? Let me use green. That'll stand out a little better. Heartbeat means go across here. So that's going to be 19. I'll put it in that color. 19.2. Over, we go up, which is h. We come back down, so it equals h. Over the length of x, which is 10.8. If you go ahead and solve all of that, I'm not going to go through it all, but it's going to be h is going to equal 14.4. So that was a method of both bunny ears and heartbeat. All right, both you need to know. Anytime you see a right triangle shaped like this and you have your altitude missing, it's going to tell you I'm probably using heartbeat or I'm going to be using bunny ears, okay? Because it only works with right triangles, so this is the setup for it. Right triangle with an altitude. Two things you think about when you're reading. If it says you have a right triangle and an altitude, you should think, ooh, this might be a heartbeat or a bunny ears type situation. All right? Questions, comments, concerns, angers, furiousness. All right, here's one that was missed and shouldn't have been. This one and this question came up a lot, so I put that one on there. So this one right here, we have two similar triangles. I have one here, and I have one big one. So the common ratio between the small one and the big one deals with that full length. So this full length here is going to be 16. This full length here is 15 plus y. Both those facts are important. Because when I want to get my common ratio, that common ratio, I'm going to do 12 over the whole length, which would be 16, which is going to be 3 over 4. My common ratio is 12 over 16. That is my common ratio. You can also do it in chunks. You can do 12 to 4 equals 15 to y, but I'm going to stick with the part to whole because it works across all platforms. All right, so our common ratio is 3 to 4. So I'm going to go ahead and solve for y. So if I'm solving for y, we're going to have 15 to 15 plus y is going to equal 3 over 4. Which means we're going to do cross multiplication. And I'll tell you what we should come up with. We should come up with y equals 5. And we do the exact same thing for x over 12. So let me set that one up. We would have x goes to 12 the same way that 3 went to 4, and you'd solve that and you'd have your x. All right, questions on that? Okay, our next one. And you're going to, a lot of you came up with this question from the review. It said basically you had an angle bisector of a triangle, and they gave you a bunch of lengths. So that's exactly what we have set up here. We have an angle bisector, and we have AB equals 18. We have AD equals 30. And we have BC equals 15. It says I'm supposed to find CD. Let's go ahead and call it X. Because it's an angle bisector, we can set up two possible situations. We can either say that 18 over 15 equals 30 over X, or we can say 18 over 30 equals 15 over X. Just make sure if you pull from this triangle, that's your top. So I have 18 and 15 on top, and I have 30 and X on the bottom. So either one of those is going to get your answer. Which one did I end up picking using? I used the 18 over 15 equals 30 over X. So I just used this one, which would be 18X is going to equal 450, and X is just going to equal 25. So CD equals 25. That's one you should have written down because we had questions on it in class several times. So you should have that written down somewhere, or at least you have that example here. All right, a 30, 60, 90 degree triangle. I like this one just because of the setup. The setup is the most important part about this. So we have a 30, 60, 90 triangle inscribed in a circle. So let's go ahead and draw it. Let's say this is my 30 degrees. Let's say this is my 60 degrees. Here's the most important part of this problem. Do you see how this is 90 degrees? It's an inscribed angle. If this inscribed angle is 90, what does it make this arc? Yeah. It's going to be 180. If this is 180, what type of line is this? If it cuts it in half, yeah. It's a diameter. So that 180 actually makes this a diameter. Which means when they say that the radius is 10, this is 10, this is 10, we can pull out this, you don't have to pull out the triangle, but I'm going to just so we can see it. We have a 30, 60, 90 degree triangle. We have a 30, 60, 90 degree triangle where the hypotenuse is 20. And remember, your hypotenuse is 2s, right? This is 2s. The one across from 30 is s, and this is s squared root of 3. So if this is 2s, s must be 10. So if 20 equals 2s, s must equal 10. And that must mean that this side is 10 square root of 3, because that is your s square root of 3. So we should already know our 30, 60, 90s, but the big takeaway is you have to know that this is your diameter radius. All right, when in doubt, assume your radius affects your triangle, right? If I say my radius is 10, assume it affects this even if you're not 100% sure. So at least you can put work down and say, I'm assuming that this is actually my diameter. Let's go from there. All right, our next one, not a hard problem, but it's hard to set up and solve sometimes. So it says that tangent B equals 8 over 15. Well, tangent is TOA, so that is our opposite over adjacent. So we just have to draw a right triangle. Let's label the top one B, little b. So if tangent is 8 over 15, that means opposite, which is the one down here, is 8 over adjacent is 15. So I have a right triangle where I have 8 and 15. In order to have sine is opposite over hypotenuse, so I need to have a hypotenuse on this guy. Did I skip right to it? I guess I didn't. So that's going to be 15 squared plus 8 squared equals c squared. I'm going to jump right to the answer of c being 17. Got it? So as soon as I have a hypotenuse, I know that sine b is going to be opposite over hypotenuse. So sine of b is going to equal 8 over 17. So it's a hard problem if you just sit there and don't do any work. If you're like, oh, how do I get from tangent to sine? It's a lot easier if you draw a picture, like I always say, at the very least draw a picture, that could have led you to getting your sine. Okay, I did change this one. I'm going to change this one real quick. I think I have like 5 more minutes. I'm going to do this. Change this 66 to 72. It's going to make our life a lot easier. So you don't get 5.5 for those that actually started the problem. So I'm going to change that to 72 so I don't kill you guys. So it says that hexagon is 72. The perimeter is 72, let's say it's 7 centimeters. Let's say it's 7 centimeters. All right, so let's just draw a hexagon. That's got 6 sides last time I checked. I haven't checked recently. How long is each side if it's 72? It's going to be 12. Yeah, 72 divided by 6. Okay. Well, to come up with an area, remember that area of the shape is going to be 1/2 perimeter times apothem. 1/2. Guess how many people forgot the 1/2? Probably about half. A lot of us just did perimeter times apothem because you're like, hey, I remember how to get apothem. Awesome. 9 multiplied by perimeter. Awesome. I'm done. It is this area equals 1/2 pa. Perimeter times area. Pa. Or apothem. So I just have to find my apothem. Well, my apothem, to get there, I have to find this angle. Well, that angle right there is just 360 divided by however many sides we have. So that's by 6. So this is 60 degrees. So my apothem is this guy here. As I usually do, I pull out that triangle. I pull out that exact same triangle. Well, this is going to be 6. This is now 30 degrees because I took that 60 in half, which makes this one 60 degrees. 30 degrees is my S. The one across from 90 degrees is 2S. So 2S is going to equal 12, although that's not important because what is important is our apothem. Our apothem is S square root of 3, which is just going to be 6 square root of 3. That is my apothem. My apothem is 6 square root of 3. So my area is going to equal 1/2. We already know our perimeter is 72. Our apothem is 6 square root of 3. Can someone give me that answer? Because I did do it with the 5.5, but I decided to make it easier on yourself. Yeah. 16 square root of 3. 216. Yeah, that makes way more sense. Oh, did other people get 216? Yeah. Okay, good. And I'm just going to put centimeters squared. Yeah, adios. All right, I think I'm going to get through these last two. I think those are the last two I have to get through, aren't they? I want to get through these because these are probably questions that we had on the homework too. All right, if I have two lines intersecting like this and we got AP equals 8, so I'm going to kind of rush through these. AP equals 8. AB equals 14, but if AB equals 14 and part of it is 8, that must mean that this is actually 6. All right, I would jump right to there. All right, and CP equals 16. I'm supposed to find PD, which I'm going to call X. Well, to solve this one, we're just going to have 8 times 6 equals 16 times X. That is how we deal with that. If I have little segments in there, we're going to come up with X equals 3. And we're done. That's it for that problem. These two. They're in review. I had lots of questions on them, so I put them on there. These are good questions. I had, on the actual test of this, is probably asked on 4 or 5 different problems these two ways, just in different ways. So you better believe it's important. So if we have two lines cutting through and they intersect inside the circle, we need to know this arc, and we can solve for these angles. All we need to do is we need to have 1/2 times 74 plus 32, and that's going to equal G. Did you get it?
I thought it was mine.
Oh. The next one's going to be, so G is going to actually equal 53. If they intersect outside, Mazen, what are you going to do then? We're going to use subtraction. If it's outside, it's subtraction. Inside, addition. Outside, subtraction. But it's basically the exact same formula, except I don't want to have negative numbers, so I'm going to do the big one. So I'll do the big arc, 214, minus the small one, 146. And what does that come out to? Did anyone get that? 34. So this one's 34 degrees. This one's 53 degrees. And the awesome thing is, if I know this is 53, I know this is 53. And then I also know that this is 127 and this is 127. So finding this one angle gets me all of these. And it also gets me this arc and this arc. So just these two things can give me everything else. All right, one last problem, and then we'll open the field to questions. I believe there's one. Yeah, one last. The reason why I'm doing this one, I'm just going to do the surface area. Because a lot of people forgot this surface area. The surface area of a cone, you're welcome, equals pi r L. It was that thing that I said you had to have memorized. You're welcome. You have to memorize pi r L for the surface area of the cone. So in this exact example, it would be pi times 15. And L is that 24. Height would be if I was doing volume. This would be your height, but that only deals with volume. With surface area, it's the 24. It's that slant. In addition to, yeah.
Don't you have to add pi r squared to that?
I was going to. Yeah, I wasn't done yet. Yeah. So we also have to account for the bottom, because I do have to paint the bottom. So we'd also have pi r squared, which would be 15 squared. And we'd add these two guys together to get our surface area of 585 pi centimeters squared. Now, if I was doing volume, remember cones are 1/3. 1/3 base times height, so you would have to actually find this h. Yes?
Do you have the answer to volume?
I don't have the answer to the volume.
225 pi rad with 31 centimeters.
Thank you, Elmer. I got that.
There you go. Awesome. All right, then we'll just open it up to questions, because I raffled through those. Yeah?
Did you go over this?
Can I go over that?
Yeah. Actually, let me erase my marking.
Yes, I can.
Okay. Don't put the -2 in there.
Well, I need it to get the whole problem.
No.
I'll erase it as quickly as it goes up. There.